First of all, let us look at the theory of refractive index. The speed of light travelling through a vacuum is always the same. When light moves through another medium, its speed slows down because the light is being constantly absorbed and re-emitted by atoms within the material through which the light is travelling. The ratio of the speed of light in a vacuum to the speed of light in another substance is defined as the refractive index for that substance. This relationship can be expressed as follows. Ri equals speed of light in a vacuum over speed of light in the substance measured. In terms of how a refractometer works, when light changes speed as it crosses the boundary from one medium to another, as well as its speed changing, its direction also changes. In other words, it is refractive. The relationship between the speeds of light through the two media, the angles of both incident and refraction, and refractive index of the two media is expressed in a simple formula. On the basis of this formula, it is not necessary to measure the speed of the light to determine its refractive index. Instead, by measuring the angle of refraction and knowing the refractive index of the layer that is in contact with the sample, it is possible to measure the refractive index of the sample. Nearly every instrument on the market utilises this principle, although many instruments may vary in optical design. Refractive index is measured as part of the characterization of liquid samples and is analogous to the way the measurement of melting point is used to characterize solid samples. Each substance has its own refractive index, and its measurement may be of value for the following reasons. Firstly, to either identify or confirm the identity of a sample by comparing its refractive index to known values. Such known values can be derived experimentally, taken from the technical or scientific literature, or obtained from the manufacturer of the liquid. Secondly, refractive index may be used to assess the purity of a sample by comparing the refractive index of the sample to the known value for the pure substance. Thirdly, refractive index can be expressed in Brix values for the measurement of sugar content of sugar-rich samples such as jams, jellies, syrups and fruit juices. The Brix value correlates to the sugar concentration in the sample measured and is expressed as the number of grams of sucrose in 100 grams of sucrose/water solution. The relationship between the refractive index and Brix is determined by the International Commission for Uniform Methods of Sugar Analysis, ICUMSA. Samples that have multiple ingredients, such as salts and sugars, such as liquid sauces like soy sauce, can be measured for total percentage concentration of these substances by using refractive index. The value can be expressed as Brix or refractive index, and the Brix value can be read and interpreted as the total concentration of dissolved materials in the sample. Neither the test method or the instrument can be used in any meaningful way without the availability of high-quality standards. They should provide traceability, which is needed to quote the results in SI units, demonstrate the accuracy of the results, calibrate the equipment and the methodology, monitor the user performance, validate the test and facilitate comparability, which is to ensure that when the correct procedures have been followed, the same analysis of the same materials will produce results that agree with each other whenever or wherever they are performed. Standards need to be affordable, widely available and certified. Reagecon standards fall into 4 different classifications. To start with, we have Brix standards, which are comprised of ICUMSA compliant and ICUMSA non-compliant standards. Both categories are available in many different values, but differ in that the guidelines from ICUMSA states that no preservatives can be added to the Brix standards, so as a result, these products have a shorter shelf life. Our range of ICUMSA compliant Brix standards are also ISO 17034 accredited. These standards have a shelf life of 12 weeks as opposed to 6 weeks from our competitors, and the non-ICUMSA compliant standards have a shelf life of 12 months. All of the standards in both categories are expressed in Brix units. Both of the other 2 categories of standards are expressed in refractive index units. The first category is also sucrose-based, have a 12-month shelf life and are accredited to ISO 17025. The second category are solvent-based refractive index standards that have a higher upper range of up to 1.65808 units at 20 degrees C and an extended shelf life of 24 months. More detailed technical information and specific product information can be obtained at www.reagecon.com either through our webshop or our knowledge centre.